Hello students, today we are going to solve numerical of ship model. Question is given as a 1:20 model of a naval ship having a submerged area of 5 meter square and length 8 meter has a total drag of 20 Newton. When towed through water at a velocity of 1.5 meter per second, calculate the total drag on the prototype when moving at corresponding speed. Use the relation Fr equals to half of Cf into rho Av square for calculating the skin resistance. The value of Cf is given by Cf equals to 0.0735 upon Re to the power 1 by 5. Take kinematic viscosity of water or seawater as 0.01 Stokes and the specific weight of water or seawater as 1000 kg per meter cube. Now first is the analysis of model. So kinematic viscosity nu will be equals to 0.01 Stokes, or we can say that 0.01 centimeter square per second, or it will be equals to 0.01 into 10 to the power minus 4 meter square per second. Now Reynolds number for model will be equals to velocity of model into length of model upon kinematic viscosity of model. So it will be equals to 1.5 into 8 upon 1 into 10 to the power minus 6. On solving this, we will have 12 into 10 to the power 6. Now for calculating the value of Cf for model, it will be equals to 0.0735 upon Re to the power 1 by 5. It will be equals to 0.0735 upon 12 into 10 to the power 6 whole to the power 1 by 5. So it will be equals to 2.82 into 10 to the power minus 3. Now frictional or skin resistance. It will be equals to half of Cf for model, rho for model, area for model and velocity for model whole square. So on putting the value of all these parameters, that is half of 2.82 into 10 to the power minus 3 into 1000 into 5 into 1.5 square. On solving this, we will have the value of frictional or skin resistance of model equals to 15.869 Newton. Now wave making resistance, that is RWM, will be equals to 20 minus 15.869. So it will be equals to 4.130 Newton. That will be the analysis of model. Now we have to analyze the prototype. Now the analysis of prototype, RW for model upon RW for prototype will be equals to RWR, we know that, and it will be equals to rho R into LR cube, which will be equals to 1 into 1 by 20 whole cube. That is, wave making resistance for prototype will be equals to 4.130 into 20 cube. It will be equals to 33040.97 Newton. Velocity for prototype upon velocity for model will be equals to length of prototype upon length of model to the power 1 by 2. So velocity of prototype will be equals to 20 to the power 1 by 2 into 1.5. It will be equals to 6.708 meter per second. That will be the velocity of prototype. Now we have to calculate the area of prototype. So area of prototype upon area of model will be equals to 1 upon LR whole square. So it will be equals to 20 square. Now area of prototype will be equals to 5 into 400. So it will be equals to 2000 meter square. That will be the area of prototype. Now Reynolds number for prototype will be equals to velocity of prototype into length of prototype upon kinematic viscosity of prototype. So it will be equals to 6.708 into 160 divided by 1 into 10 to the power minus 6. So Reynolds number for prototype will be equals to 10.73 into 10 to the power 8. So Cf for prototype will be equals to 0.0735 upon Re for prototype to the power 1 by 5. On putting the value, that is 0.0735 divided by 10.73 into 10 to the power 8 to the power 1 by 5, it will be equals to 1.49 into 10 to the power minus 3. That will be the value of Cf for prototype. Now, frictional resistance on the prototype. It will be equals to Ff for prototype will be equals to half of Cf for prototype, rho of prototype into Vp square for prototype into area of prototype. On putting the value, that is half into 1.149 into 10 to the power minus 3 into 1000 into 6.708 whole square into 2000. On solving this, we will have the value of frictional resistance on the prototype equals to 51701.86 Newton. Now we have to calculate the total drag force on the prototype. So it will be equals to Ft will be equals to Ff for prototype plus Rw for prototype. So it will be equals to 51701.86 plus 33040.97. On adding these two values, we will have 84742.83, which will be nearly equals to 84743 Newton. That will be the total drag force on the prototype. That is the complete solution for this numerical. Thank you very much, students.